Cars today are stuffed with safety technology, and among the most important pieces are the headlights. Headlights play a significant role in shaping a car's overall appearance and personality. Their design can contribute to the vehicle's aesthetic appeal and help define its unique character, making them a crucial aspect of automotive design and styling. Headlights today are undergoing some of the biggest technological changes seen in the history of the automobile. From carbide lamps used in the early days of cars to laser lights of the modern era, automakers have worked toward this goal by improving the bulbs used and by building features into them, such as the ability to swivel headlights back and forth to follow the turns of the steering. In the earliest days of the automotive industry, headlights were not a top priority for drivers because most people wouldn't bother driving at night simply because of the roads. During this period, roads were often unpaved, rough, and largely non-existent. Also, cars were less reliable and more prone to breakdowns compared to modern vehicles. At that time, driving at night was very challenging without proper lighting on the roads, making nighttime travel difficult and hazardous. To solve this problem and make nighttime travel possible, headlights were introduced. The earliest headlights were found in the late 1880s. These were fueled by xylene gas or oil. Back when cars were in their infancy, headlights were actual flames burning behind glass lenses and fed with acetylene gas. They were quite similar to the gas lamps used in homes during that time. Carbide lamps consisted of two parts. Solid carbide was placed in the lower section and water filled the upper. The water dripped down into the carbide, where it reacted to produce acetylene, a flammable gas. This gas traveled through a pipe to the end of the lamp, where it was burned to emit a bright light. A valve allowed for the adjustment of the amount of water dripping from the upper chamber, which in turn regulated the volume of acetylene generated. However, the drawback was that the calcium carbide tablets and the water needed to be replaced regularly. These early headlights typically consisted of a lantern-like structure with reflecting mirrors positioned behind the flame to direct light forward, although the beam itself wasn't particularly focused. This made them less effective at night because the light scattered into the night sky rather than being directed at an object or the road ahead. Also, the main drawback was the buildup of caustic lime, which is a byproduct of the combustion of acetylene gas. This lime could accumulate on the lamps and require frequent cleaning. Additionally, handling acetylene gas can be hazardous due to its highly flammable and reactive nature. In 1904, several car manufacturers offered pressed oil, calcium carbide, and acetylene gas generator cylinders with gas feed pipes for lights as standard equipment. With all these issues, acetylene lamps weren't ideal, but they got the job done, at least until electric headlights made their entrance a decade later. The first electric headlight was introduced in the year 1898 by the Electric Vehicle Company. In 1904, American automaker Peerless was the first manufacturer to introduce electric headlights across its range. 4 years later, British-based supplier Pockley Automobile Electric Lighting offered a complete set of electric lights, including headlights, taillights, and side lights, which were powered by an 8-volt electric battery. That early attempt was optional and faced challenges, such as light filaments, that would not stand automotive use due to their short lifespan and weak environmental resistance. Additionally, manufacturers struggled to produce dynamos small enough to fit in the car and still produce enough power to light the bulb. However, they weren't very functional until much later, when Cadillac introduced the Delco electrical ignition and lighting system in 1912. The Cadillac Model 30 became the first car with an electric system. Apart from the new headlamps that could be used even during rain or snow, it also had an electric ignition and an electric starter instead of a hand crank, with better range, lower weight, and higher convenience compared to the electric vehicles of the time. Once the headlights went electric, car manufacturers began exploring ways to enhance and amplify the light output. By the mid-1910s, it became clear that using a mirror behind the headlight to enhance the light was not the only option. Engineers began experimenting with special optics directly on the headlight lenses themselves. Surprisingly, this approach didn't emerge sooner, especially because similar technology had been used in other fields, such as lighthouses. In lighthouse design, the objective is to intensify and direct a beam of light to guide ships safely. The use of such optics in automotive headlights was a logical step, resulting in improved visibility and safety for nighttime driving. When you picture old classic cars, you probably imagine cars with sealed beam headlights. By 1939, sealed beam lights had been introduced and became compulsory on all vehicles in the US between 1940 and 1983. They used a parabolic reflector as well as a lens and a filament sealed together to offer a brighter, more focused light. The main drawback of these headlights was that, despite their high power consumption, early sealed beams produced a relatively small amount of light. Additionally, the boiling filament would often leave dark residues on the glass, which further limited the amount of light that passed through. A significant benefit was that no water from rain, wet roads, or cleaning could enter and obscure the light. But this did mean that if one bulb inside the sealed beam got damaged, the entire light would need to be replaced. To counter these issues, automakers made improvements over sealed beam headlights and came up with the idea of new headlights known as halogen headlights. In the early 60s, halogen headlights instantly became the standard tech in Europe. In 1962, a French, German, and Italian consortium of bulb and headlamp makers produced the first vehicle-mounted halogen lamps. These provided brighter, more durable headlights due to the way the halogen gas reacted with the tungsten. This process gave drivers much higher road visibility, particularly on high beam settings. Halogen bulbs are undoubtedly the most traditional and widely used headlight bulbs of all time. A halogen headlight works by taking advantage of a thin tungsten filament mixed with inert halogen gas, contained in a piece of glass that is highly resistant to heat. When your headlights are activated, the electric current is passed through the glass capsule into the tungsten filament. This heats the filament up to around 2,500 degrees Celsius, which results in the tungsten glowing. The light from a halogen bulb is yellow due to the heated tungsten and inert halogen gas reaction. An ordinary light bulb uses a wire filament that heats up and emits light. Meanwhile, halogen lamps use halogen gases such as bromide and iodide that help redeposit evaporated tungsten atoms back onto the filament. This regeneration process extends the lifespan of the bulb and allows it to operate at higher temperatures, resulting in a brighter light output compared to traditional incandescent bulbs. Standard halogen headlights burn with a slight yellowish hue that measures roughly 3,000 Kelvin on the color temperature scale. There are some bulb manufacturers that make 3,400 to 4,200 Kelvin halogen bulbs, but those aren't street legal in most places. In other words, the higher on the Kelvin scale you go, the whiter the light. The Kelvin scale for car headlights typically begins at about 2,500 and goes to about 4,600. Overall, the Kelvin scale goes as high as 10,000, but that's the intensity of bright sunshine under a blue sky. This is a nice, comfortable glow that does the job well, but if you prefer bright white lights with a bit more range, you may want to consider another type of headlight bulb that's higher on the Kelvin scale. Two of the primary downsides to halogen headlights were the fact that they just didn't last as long as many drivers wished, and the range of light wasn't fantastic. This led to the introduction of Xenon, also known as high-intensity discharge headlights. Rather than using a single tungsten filament, Xenon lights have a quartz housing with electrodes on either end, with xenon gas in between. When activated, the charge passed through the housing produces a spark that ionizes the gas and creates a current between the two electrodes. Xenon gas is commonly used in it, along with various salts known as metal halide salts. Light is created when an electric arc passes through the gas and salt mixture, heating it up. Once this power reaches a certain level, something known as a ballast activates, which keeps the current going steadily. Xenon headlights typically last 5 times as long as halogen lights because the halogen requires more energy to run. This is because xenon lights use an electrical discharge to create light rather than a filament that can burn out over time. There's a very high initial voltage that creates a flash, but then there's a relatively slow ramp up to full brightness. These lights give a range of 4,000 to 6,000 Kelvin on the color scale. They give a true whitish color light and a premium look to vehicles. Because it takes a few seconds to attain full brightness, HID isn't suitable as a separate high-beam headlamp, TIVOTted. Most cars with HID lamps use halogen lights for high beams, but some pricier models have bi-xenon lamps. These use HID lighting for everything, but when the low beams are on, a mechanical shutter reduces the amount of light. When the high beams are activated, the shutter lifts up to let all the light through. HID headlights are much more powerful and brighter than conventional halogen headlamps and have a throw of around 200 to 250 meters. When compared to halogen bulbs, xenon headlights are expensive and complex. They require a warm-up period to reach full brightness. Over time, xenon bulbs lost their crisp white color and developed a bluish hue. Also, they were less durable compared to LEDs. The lifespan of xenon lights was relatively short-lived due largely to the problems they posed. This led to their quick replacement by LEDs, which offered superior performance, reliability, and durability. The LED bulbs are illuminated by a long fancy term called electroluminescence, which means electrons are fired toward positively charged holes in a semiconductor. Thus, they release energy as photons, which are particles of light. The LEDs require minimal energy to light up and have an exceptionally long lifespan. In contrast, the thin filament in a halogen bulb degrades over time, eventually causing the bulb to fail. LEDs, on the other hand, do not rely on a filament. Instead, they use a semiconductor that emits photons when an electric charge is applied. The operation of LEDs is quite straightforward. They don't need any warm-up time, and there is almost no heat emitted. They are the most energy efficient and produce bright light, making them even more efficient than halogen and xenon bulbs. Also, these headlights can throw light up to 300 meters and are available on premium cars that make various shapes through the use of LEDs. They come with numerous designs, and manufacturers can fit them anywhere. These have also been used for indicator lights, vehicle stop lamps, tail lamps, interior lamps, and more. They actually didn't exist until 2004, when Audi's A8 brought them onto the scene. As with most tech in its first few years, the first wave of LEDs provided spotty performance at best. Even with their gains in efficiency, the LEDs can be designed to emit any color of the spectrum. They can produce a bright white light that illuminates up to a mile ahead without blinding oncoming traffic. LED lights usually range from 4,000 to 6,000 Kelvin on the color scale. For those who are considering making aftermarket adjustments to their vehicles, be aware that LED headlights require specific technology and a specific housing for the LEDs. Simply throwing LEDs into a halogen or xenon housing will not work at all, and the reflection of the light will be all off coming out of your headlamp. Adaptive headlights use the same LED bulbs but simply go further to enhance the driving experience. These headlights are designed to improve visibility while driving at night or in low-light conditions by moving the headlights in sync with the steering wheel. The idea behind this is to enhance the driver's visibility around curves and corners, reducing blind spots and improving overall safety. A car with adaptive headlights uses electronic sensors to detect the speed of the car, how far the driver has turned the steering wheel, and the yaw of the car. Yaw refers to the rotation of the car around its vertical axis. Monitoring yaw helps the adaptive headlights adjust to the vehicle's orientation and predict the curvature of the road ahead. The sensors direct small electric motors built into the headlight casing to turn the headlights. A typical adaptive headlight can turn the lights up to 15 degrees from the center, giving them a 30-degree range of movement. An early example of an adaptive headlight was found on the Tucker 48, also known as the Tucker torpedo, invented in the late 1940s by Preston Tucker, a former policeman. The Tucker 48 was a remarkably innovative and futuristic vehicle that never made it to mass production. The Tucker 48's third, centered headlight, often referred to as the Cyclops Eye, was designed to turn in conjunction with the steering wheel to improve visibility around corners at night. Matrix headlights take adaptive lighting to the next level by using an array of individual LED modules that can be controlled independently. The matrix lamp consists of several smaller LED lights that work together in one headlamp. This allows for more precise control of the light beam pattern. Matrix lights are often referred to as smart lights or pixel lighting. Matrix headlights use a camera and sensors to detect oncoming vehicles. As soon as it spots a car coming from in front, It automatically adjusts the beam pattern of the headlights to avoid dazzling other drivers while still providing optimal visibility. This means that the driver does not need to switch to a low beam, as it is done automatically by the system. Matrix headlights can selectively dim or deactivate specific segments of the light beam to create a variety of light patterns. This capability enables them to adjust dynamically to different driving situations, such as urban areas, highways, and curves, without dazzling other road users. Today, lasers change the game. While LEDs or halogen headlights are pretty much the standard for most cars now, laser headlight tech is emerging as a possible new alternative. At this point, laser headlights offer an impressive line of vision and unheard-of efficiency. A laser headlamp consists of one or more laser diodes built into it. The diodes emit a blue laser light. This light is directed by a mirror towards a compartment filled with yellow-colored phosphorus gas. When the yellow phosphorus comes in contact with laser beams, it creates a chemical reaction and gives out intense white light. The white light produced by the laser lamp is powerful and bright. Currently, lasers are limited to just a handful of prototypes or pricey limited edition models, such as the optional laser high beam headlamps on BMW's i8 hybrid sports car. The entire unit is very compact, and these smaller assemblies could be easier to fit into upcoming vehicle designs. Lasers can also be twice as power efficient as LEDs, but they are also the most expensive ones. Laser headlights can be up to 4 times brighter than LED lamps, and their range can be twice as long, letting drivers see much farther down the road. Another benefit of this headlight is that it burns in a range of 6,500 Kelvin, similar to natural light. These are the main types of headlights that are being used by the manufacturers. Just like any other technology, as time passes, the technology will evolve more, and it will be able to trickle down to vehicles that cost much less. So, that's it. What do you think about these headlights? Which one do you prefer the most? Let me know in the comments, and finally, thanks for watching.